Hello world and welcome to another Funza Academy video. Before I continue with today's problem, we would like to give a big shout out to our strong supporter of our channel, Vincent Voltaire. Vincent, thank you so much for your motivating comments. It's comments such as these that keep us going. Thank you. Okay, now coming to today's problem. Today's problem is an example of thinking out of the box. It's a problem that is interesting and involves a bit of patience. So here it is. ABCD is a square of side x. E is a point on the two-dimensional plane. The length of EA is 5, EB is 2, and EC is 4. Find the area of the square in terms of x. Please pause the video and give the problem a try. If you do not wish to solve the problem, please write down how you will approach it. And then check your approach with ours. Okay, so welcome back. So we will first try and get some order into this problem. We have got some known values such as 2, 4 and 5 and one unknown x. Let's see if we can relate the two and come up with a value of x. Our friend that will help us do so is the Pythagoras theorem. But first we need some right-angled triangles. So here is one, here is another, and finally here is another. Now we will introduce two more unknown values, A and B. Now this is interesting, isn't it? We wish to find one unknown, but now we are introducing two unknowns to find our one unknown. Ah, the wonders of life. And that is the fun bit. Somehow by introducing more unknowns, we will find our unknown. Now let us focus on our right-angled triangles and find relationships between our unknowns. So let's first look at triangle EBF. Using Pythagoras theorem, we can say EB square is equal to EF square plus BF square. And here is our first equation. Now let's focus on the next triangle, ECG. We can say EC square is equal to CG square plus GE square. And simplifying this further we get, but we saw in our previous equation that A square plus B square is 4. So let's put that 4 in here. Now we will solve for A, and this is what we get. Now at this point you might say, why are we solving for A when we want X? And that's a good question. Actually, we are not solving for A. We are getting A in terms of X. This means that later we can replace A with X, and that will help us arrive at X. We will see this shortly. Okay, so this is our second equation. Now guys, let's come to our third triangle, EAF. And again, this is a right angle triangle, so we can say EA square is equal to EF square plus FA square. And simplifying this further, we get, but we saw in our previous equation that A square plus B square is 4, so let's put that 4 in here once again. And now we will solve for B, and this is what we get. So now we have both A and B in terms of X. But how does that help us? It does help us, and we can use it in this equation. Notice how this equation is in terms of A and B, but since we calculated A and B in terms of X, we can rewrite this equation in terms of X. And we have an equation in X. And if we have an equation in X, we can solve for X. Now here's our equation, and it definitely looks complex. Let's see if we can do something about this X square here. X square is the area of the square. So let's simplify it by replacing this X square with U. And this is what we get. And simplifying it further, this is what we get. So here, my friends, what we have is a quadratic equation. And to solve it, we will use a formula by Brahmagupta, an ancient Indian mathematician and astronomer. So here's the formula on the left. We will replace the values of A, B and C with the values in our equation and solve for U. And once we do so, these are the two values we get. And further solving, we get the values of U. But which value is the correct one? Can you please pause this video and try to figure this out? Okay, we can find our answer by looking at one of our equations. Say this one. We know that we have two values for U, 9 and 32. But what is U? U is nothing but x square. And here is A in terms of x. Can a be negative? It cannot. So 12 minus x squared cannot be negative, right? And if x squared is 9, then it will not be negative. But if x squared is 32, we get minus 20, which is negative. This means that x squared, or u, has the value of 9. So finally we can say that the area of our square is approximately 9. Oh boy, that was quite a lengthy problem. Okay guys, so I hope you enjoyed this problem. It had so many ingredients. Okay, it required patience, it required knowledge of algebra, the Pythagoras theorem, a few more things, quadratic equations. But as you can see, once all these pieces came together, you arrived at a beautiful answer. Thank you very much.